So we will have a bipolar junction transistor. BJT is a short form for this bipolar junction transistor. It is a type of transistor. Dia ada banyak jenis transistor ni. For our syllabus, we only cover for the BJT. Okay, transistor is actually to control the electric current flow between 3 layer. 3 layer apa? 3 layer apa? We have a transistor between 3 layer. Okay, for the 3 layer, it is N, P, N. Ataupun P, N, P. Okay, remember chapter 2, what did we have learned in chapter 2? Diode. So for the diode, we have how many layer? 2. Let's say N and P. That one is diode. Okay. Diode simbol dia macam mana? This one kan positive, negative. Okay. For the transistor, it is 3 layer. It's like sandwich. We add on another 1 layer into the diode. Okay, into the semiconductor diode. So it will become NPN. Okay, for the diode, since for the diode we have the depletion region kat tengah ni kan. Okay, for the transistor also we have the depletion region. It's like sandwich ataupun wafer kan. Dia ada 3 layer. Okay, in between ada inti pula. Like burger lah, kat tengah tu ada the patty. Okay, so this one is for the transistor. Enhancement from diode, dia dapat the transistor for 3 layer. It can also have the P and P. Sama juga. Okay. And for the transistor, for diode, dia ada current flow. And diode normally we use as switching. Same goes for the transistor. Pun sometimes we can use as a switching. Rather than that, we can also use as amplifications. Kalau you pernah tengok amplifier, op-amp, okay, that one dia guna transistor. And also penting dalam signal processing. Okay, used in electronic circuit for amplifications, switching, and also for signal processing. Okay, used as switch in oscillator, in temperature sensing. Okay, ada 2 jenis, NPN and PNP. Sama macam diode, ada PN and P, 2 jenis. Okay, for the for the transistor, they will have 3 kaki lah. Okay, they will have 3 pins. Kalau diode ada 2 je, positif, negatif. Transistor will have 3 pins. Sekejap lagi kita tengok. And what else? The applications used in electronic devices like mobile phones, TV, radio transmitter, industrial, central, and also in audio amplifications. Sebab kita normally lah for this transistor, kita guna dekat dalam amplifier, op-amp. So that is why dia banyak guna dalam amplifications audio. Macam PA system tu, we have the input signals and then you nak deliver suara yang lebih kuat kan. Okay, same goes dalam telecommunications, radio transmitter. Okay, we have op-amp. There are the few classes of op-amp. Okay, this is the first BJT. Yang paling simple is the BJT for transistor. There ada few jenis. FET, this one is for your knowledge saja. FET is field effect transistor. Okay, kalau for the BJT, simbol dia like this. Okay, dia ada current flow. Dia ada anak panah dekat sini. For the BJT. Okay, for FET, simbol dia. Okay, dia ada anak panah in here. Okay, the arrow indicate for the NPN ataupun PNP. Kalau NPN, arrow dia keluar. If PNP, arrow dia terbalik lah, masuk. Okay, ataupun arrow dia dekat belah atas, meaning that current yang masuk. Nanti kita tengok dekat setiap kaki dia. So for FET, simbol dia like this. Other than that, we also have MOSFET. MOSFET simbol dia is okay. And then we have MOSFET. MOSFET is metal oxide semiconductor field effect transistor. MOSFET dia tambah enhancement. Okay, simbol dia lain sikit. Okay, this one dia line yang straight line. Okay, this one is dotted line. For MOSFET dia dotted line. Okay, dia ada lagi MATFET, depletion MOSFET. What else? Okay, itu antara yang basic. But then the most simple one is BJT. So we only cover for the BJT. BJT is voltage control current devices. So what are the important bila kita sebut voltage control current? Dia related with voltage dan juga current. On the operations, dia mesti antara dua ni yang penting. Okay. What else? Okay, this is all the objective yang kita akan cover. Okay, basic constructions and operations of the BJT, and what are the biasing. Like in previous chapter 2, we have forward bias and reverse bias kan. Okay, in chapter 3 we also have on the biasing and configurations. Okay, we have the saturations and cut off conditions, and this one is characteristic of NPN and PNP. Okay, we will relate that one with the flow of the current. Okay, and important parameter nanti kita akan tengok. Alright, and this one importance AC parameter for an amplifier. This one is for the small signal AC analysis. Okay, why I mention small signal? Because we will have AC equivalent circuit. That one is a small signal analysis. Okay, we will convert the DC circuit into AC equivalent circuit. Okay, so this is a history of the BJT. As you guys can see, okay, this is symbol dia tadi, yang ni. Okay, this one is PNP. Okay, so simbol dia adalah kat sini anak panah masuk. Okay, kalau dia is NPN, semua ni kita guna for switching ya. Selain pada switching, boleh jugalah guna for amplifications. Okay, dia boleh lukis ada bulat ataupun tak ada the circle. Okay, kalau for NPN, arrow dia keluar. Yang ini kan dia masuk. This one, yang ni So for NPN dia keluar. Okay, nanti kita akan tengok on the flow. And ini adalah kaki dia, terminal dia ada 3. So here is base. Kat tengah is base. This is emitter yang bawah. Yang atas is collector. Kita tengok gambar dia lukislah sekejap. Okay, collector, emitter dengan base. V and I is the voltage and current, meaning that dekat setiap terminal must have dia punya voltage and the current. Sebab tu you ada VC, IC, VB, IB, VE, IE. Okay, and yang dekat tengah ni pula VCE, VBE is in between, voltage in between dia. Okay, dia ada in between voltage. And for VBE, this one is equals to 0.7, same value as the value diode. VBE all the time must be 0.7. Okay, in the calculations dia takkan beri dah value of the VBE, because by default all the time VBE is equals to 0.7. Okay, nanti kita akan tengok lagi detail. That one is in DC analysis. Okay, for voltage and current, value yang kita akan kira in DC analysis. Okay, alright, so this is history for the transistor. Dulu-dulu punya, I think dalam 30 years back, 20 years back, kita pakai TV yang jenis tebal punya, bulky one. Same goes with the computer kan. Okay, during your time bila kat sekolah, komputer dah flat, betul tak? Tak flat lagi, yang gemuk tu. So tapi TV dah flat, gemuk juga. Macam jauh je umur kita. Okay. And dulu punya TV yang bulky tu, yang gemuk sekali nak angkat tu, dah macam besar meja dah kan. Okay, that one dia tak pakai transistor, dia pakai vacuum tube dekat dalam. So yang belakang dia tu, yang panjang tu, because of the vacuum tube. So vacuum tube yang panjang, dia nak pancarkan the signal supaya dia keluar dekat screen. Itu fungsi the vacuum tube untuk TV yang dulu lah, screen yang dulu. Okay, dekat dalam ni. Inilah TV nya kan. Okay, yang belakang ni, the circuits yang kat dalam ni dia ada sinilah dia punya vacuum tube. Okay, siap ada peti almari lagi kan untuk TV zaman dulu. Cantik, tak payahlah nak pakai kabinet-kabinet. Okay, so this one is the development of the vacuum tube. Tahun 1941 use the vacuum tube, and then over the years dia dah ada germanium, and then after the years dia ada silicon transistor, and dalam nak masuk 1960s tu dia dah ada IC integrated circuit, meaning that this one dalam IC integrated circuit, all the components electronics dia dah embed dekat dalam smaller circuit. Okay, macam ni lah dia dah embed. Okay, so from the circuit yang besar macam ni, dia boleh dapat yang smallest like this. Tapi ni tahun dekat US. So nak datang teknologi tu dekat kita, dia takes time kan. Kita dalam around 90s, 2000 macam tu baru dapat all these technologies. Okay, and this one barulah diorang dapat silicon wafer. Silicon wafer ni is the transistor yang the smallest one lah. Okay, sebab tu after this years terus laju nak evolve for the smartphones, apa tu yang smart charging pula, smart devices semua kan. Okay, and harga pun makin murah. Okay, so this is history lah, macam mana orang zaman dulu tengok TV yang besar-besar tu, segala-galanya ada dekat dalam the TV. And now because of this IC, all this electronic circuit become smaller and lagi senang nak fabricate. Okay, alright, so this is for the transistor construction. Okay, bipolar transistor is produced when a third layer is added to a semiconductor. Like I have explained before this tadi. Okay, we have two layer, P and N, two compound, and then kalau kita tambah another one, kita akan dapat NPN ataupun PNP. What is the difference? Ada yang tanya saya, the difference between NPN and PNP. Katakanlah for this both kita guna dalam switching. Okay, kalau kita guna dalam switching, for NPN normally dia by default, kalau on adalah 1, off adalah 0. Check, yes. Okay. Okay, contohnya 0, 1, 0. Okay, so 0 is low, off. 1 is high, on. Okay, by default. Tapi for the PNP dia terbalik. 1, 0, 1. Kita nak this one is off, this is on, this is off balik. Okay, so for the PNP, it reverse operations from the NPN. Okay, and there is situations where we need switching dia kena terbalik. High dia off, low baru dia on. Okay, there are other situations for this PNP punya switching. Okay, tapi in between NPN dengan PNP, NPN lagi widely used lah. Okay, alright. Second point here, a transistor can amplify power. Sebab tu dia guna dalam amplifier. Okay, current or voltage. Okay, kalau kita amplify voltage, kita dapat voltage gain. Voltage gain is the AV. If we amplify current, kita dapat current gain. Current gain is AI. Okay, AV, V out over V in. Voltage out over voltage in, the ratio. Okay, AI sama juga. I out over I in. Meaning that we must get the value for the input. Input normally will be given lah. And juga value dekat the output. Okay. And for the power, AP, saya tulis kat sini lah. AP, AV darab dengan AI. Dia guna V darab dengan I kan? Power kan? Okay, so it comes from that. AP equals to AV multiply with the AI. Okay. For this transistor, kita ada dua jenis juga, germanium and silicon. Okay. But then sangat jarang orang guna the germanium. Normally apply on the silicon. Okay. And this one, this is not new things for you. Okay, consists of 3 alternatively doped region. Kalau in before this, we have learned in semiconductor 2 doped region. Okay, for transistor 3 lah, sebab kita ada 3 layer. Okay, and the regions are arranged in 2 ways. For P-type, sandwich between 2 N-type material, NPN semiconductor. And then for N-type material is sandwiched between 2 P-type material for PNP semiconductor. Okay. How to determine? You tengok dia punya simbol error dia. Yang ni lah. Okay. If this one, this is NPN. Okay, kalau error keluar NPN, sebab dekat setiap terminal dia ni dia ada current. So this one is current masuk, so current akan keluar, IE. Sebab yang bawah normally is emitter. This is base, yang atas is collector. So IC akan masuk, IB akan masuk. So from the Kirchhoff current law, IE is equals to IC plus I. Yes. So kita still bawa knowledge from chapter 1 kan. Okay. Ini baru current. Sekejap lagi kita tengok on voltage. Kalau bukan sekejap lagi maybe in chapter 3B. Okay. And this is common types yang kita add in the doping process. For P-type, kita add with boron and gallium. For N-type, add with phosphorus and the arsenic. Okay. This is in doping process. Alright, so this one is 2 types of transistor that we have, PNP and the NPN. Okay, this is for PNP. Okay, apa yang beza for PNP and NPN ni? This is PNP. This is NPN. Ni kan? Okay, kalau untuk for PNP, IE akan masuk, dia akan keluar. Tapi dia still carry the same, IE equals to IC plus IB kan. Cuma yang ini dia akan masuk through the IE. For this one yang bawah, IC will goes in, IB also goes in. So dia akan keluar kod IE. Okay, sama je. It just dekat IE ni dia masuk, tapi ini dia directions dia terbalik. Kan? Okay. Alright. So yang ini, this one is the size of the each layer. Okay, as you guys can see, layer base is a very thin, paling nipis kan. Okay, and this one is the ratio. Katakanlah ratio dia adalah 1/150 kot kan. Antara base dengan yang lagi dua, E dengan C. Lebih kurang lah. Okay, and because of the very thin layer, IB is very small. Nak kata approximate 0 tak jugalah. This is IB the smallest current dalam normally dalam microampere, the smallest value. Kalau you measure tiba-tiba ataupun you calculate tiba-tiba IB dapat value paling besar, mesti salah. Something is wrong in the calculation. Okay, value dia normally dalam microampere for IB, for both PNP ataupun NPN. Okay, IB is the smallest one. IC and IE dia lebih kurang dalam milliampere. And let's say because of I mentioned IB is the smallest one, sometimes we can assume that IE is approximate to IC. Because this one kalau terlalu kecil, maybe lagi kecil dari microampere, we can consider as 0. Tapi dia tak adalah IE equals to IC, dia approximate. Okay, let's say kalau in calculations kita kira-kira tak dapat juga. So you can assume IB is equals to 0, then you boleh guna IC equals to IB. Okay, and one more relationship, IC is equals to beta IB. Okay, kita tak boleh nak terus assume IB is equals to 0. Right. IC is equals to beta IB. What is beta? Beta is the ratio value given datang sekali with the BJT. Ini adalah dia punya constant value. So dia mesti given the beta. Beta value must be given. Okay, lagi satu relationship dia adalah IE equals to 1 plus beta IB kan. Kalau kita masukkan the beta dekat dalam yang bawah ni, okay, gantikan IC dengan beta IB, so you boleh dapat 1 plus beta IB. Nampak tak? This one, IC ni, this IC ganti dengan beta IB. So faktorkan, keluarkan IB, boleh dapat this relationship yang atas tu. Kan? It's just substitution. Tapi yang important is 3 ni lah. Bukan 3, 2 je. Yang IE equals to beta IC, IE equals to IC plus IB, that one is common. Okay, this is yang penting lah. Okay, alright, this is the terminal, emitter, base and collector. Base is lightly doped because of the thin region, and value of the base current is the smallest one dalam microampere. Okay, for emitter is, kalau base lightly doped, emitter is heavily doped. Okay, sebab dia yang paling tebal. And normally value of the emitter is the largest one. Okay, collector is moderately doped. Okay, this one heavily doped. Ini lightly doped. Ini moderately. Okay, for collector. Okay, this is explanations yang ratio tadi. Ratio of the total width to that the center layer 150 to 1. Okay. Alright, so this one same as in previous chapter 2 that we have learned in semiconductor. For each of the region, dia mesti ada concentration gradient, perbezaan gradient antara majority and minority. Kan? Because we have two different types, P dengan N. When we put it together, satu majority dia electrons, another one majority dia holes. So when we put that two together, dia akan effect lah. Same goes for this one. Yang ini at this side. Okay, and at the other side is this one. Okay. And ini, the concept is same as the semiconductor. When we put an external electric field, dia akan ganggu on the concentration gradient in the PN junction itself. Okay, this one is, ini apa bila kita tak ada the depletion region? Bias, forward bias. Okay, for this one is depletion region is wider, it is reverse bias. Okay, same concept, same explanation as in chapter 2. Okay. And okay, so saya nak padamkan dulu. Now kita nak tengok on the current flow. Okay, so for here forward bias, IE will goes in. Sebab tu kat sini is the PNP. Sebab dia masuk through the IE. Okay, and then IB will goes out, keluar kod sini, kod IB, kod base. And IC keluar dekat collector. Okay, so this one is IE equals to IB plus IC. Okay, please do not conclude IB is straight away equals to 0. Okay, you need to measure to calculate first. Kalau memang dapat the value is too small, then you can assume as 0. Kalau nanoampere, then you can assume as 0. Ataupun when you tak boleh buat dah, bila kira-kira memang tak dapat, so you can assume as 0. Okay. Okay, so this is current in the transistor. We have the 3 terminal, collector, base and emitter. And IE is equals to IC plus IB for both PNP ataupun NPN. This is the same one. And this is for the leakage current. Leakage current is the current leakage kan bocor kan, current yang kita ignore. Okay, we have the IC majority plus IC minority. Remember that what we have learned in chapter 2, we have diffusion current and the drift current. Okay, this one is actually on the drift current, diffusion current. Current yang we ignore because the value is too small. Okay, by ideally dia ada, tetapi in theoretical dia ada, but then in practical we are not considering on the value. Okay, for the leakage current. Okay, the collector current is comprises of 2 current, IC majority and IC minority. Okay, as you can see for this one, majority carrier is from IE positif kan, banyak positif kan, yang tengah is banyak negatif. Okay, so from there dia akan ada juga drift current and also the diffusion current. So that one is on the minority current ataupun the leakage current. Okay, alright, so this one like I mentioned tadi, if the IB value is too small, then we can consider IB is equals to 0. So from this one to yang dapat IC approximate to IB kalau this one is 0. Okay. Ataupun in the question, if it is stated that IB is a small value, then consider no value for the IB, then you can ignore. Okay, terus boleh guna these expressions lah. Okay, so this is 3 terminals BJT, 3 terminals devices. We have connected to the input and output. Okay, contohnya kalau connected to the input and output, this one connect to the input. Normally base will connect to the input and the collector will connect to the output kat sini. Okay, V in dengan V out. And ground normally, E normally akan pergi ke ground. Okay, a transistor amplifier is a 2-port network. Dia ada input and output. Kalau 2-port, we have input and output port. One of the 3 transistor terminal must share the both input and output port as the common terminal. Okay, for these configurations ataupun connections for the transistor, kita ada 3 types. Kita ada 3 jenis. Common emitter. Normally for common emitter, the emitter will connect to the ground. Okay. And then common base. Number 2 is common base. The base it will connect to the ground. And common collector. Kalau common collector, connector yang akan connect to the ground. Okay, and for all these 3 configurations, why we have 3 configurations depends on the applications. Okay, this is the specifications for each of the configuration. Okay, common base has voltage gain but no current gain. Voltage gain tadi apa? AV. Current gain AI. If we have voltage gain, maksudnya dia ada value. It is not 1 ataupun not 0. Okay, AV is equals to V out over V in kan. So we have voltage gain. The voltage gain can be in terms of positive or negative value. If it is in negative value, meaning that dia punya polarity, dia punya pulse ataupun dia punya cycle dia just terbalik. Because let's say kalau input V in is signal macam ni, so V out mungkin dia akan dapat signal, so dia amplify tetapi in opposite cycle. Okay, katakanlah this one maximum dia 5, this one maybe maximum dia 50. Okay, nampak tak? Minus 50 lah because dia cycle bawah kan. Okay, so ini is in opposite cycle lah. Okay, no current gain meaning that the current gain is equals to 1 unity. Dia kan I out over I 1. Dia tak ada gain. Maksudnya value dia sama. It is not 0. Katakanlah current masuk 5, current keluar pun 5. So apa gain dia? Tak ada. That is the meaning by no current gain. Okay, dia bukan 0. Kalau 0 maksudnya sama ada I out ataupun I in yang jadi 0 kan. So for no current gain, it is the value of the ratio sama ataupun kita boleh katakan it is unity current gain. Sebab dia equals to 1. 1 kan unity. Nampak tak? Confused. Fatihah okay? Lagi? Rizwan? Okay, sebab dia no current gain is equals to unity current gain. Dia tak ada increment. Value masuk sama dengan value keluar. Okay. Alright. For the second one is emitter configuration. A common emitter. This one is common base. Ini common emitter. Ini common base. Okay. For common emitter, this is the most efficient one sebab dia ada both. Dia ada, it has the current gain AI, ada value. AV pun ada value. Okay. That is why among these three, the common emitter yang paling banyak guna. Normally dalam amplifier lah. Okay. For common collector, dia terbalik from the common base. It has AI. AI dia ada value. Tapi voltage gain dia tak ada. So voltage gain equals to 1. Equals to 1 ataupun approximate to 1. So, kadang-kadang bila kita kira dapat 0.98, 0.99, 1.01, 1.001. So it is approximate to 1, approximate to unity. Okay, so that is for common collector. Okay, so we have three configurations: common base, common emitter and common collector. For the applications depend on the purpose. Circuit kita tu kita nak guna untuk apa? So that is kita apply each of this one lah. Okay, normally kalau amplifier dia biasanya guna common emitter sebab amplifier memang kita nak amplify. Okay, amplify on the current ataupun on the voltage, and then if the purpose is to amplify on the power pun sama kan, AP equals to AV darab AI. Okay, alright, so ini adalah contoh connection dia. For common base, ini adalah emitter. First thing to determine, tengok anak panah dia. Anak panah dekat mana, that one will be the emitter. Okay, the opposite side will be the collector. The middle one will be base. Okay, tu first thing. Okay, for this one, common, ini emitter, collector, ini base. Okay, and each of the terminal tu dia boleh ada resistor ataupun capacitor lah. Okay, this one is emitter, base, collector. Okay, yang ini common base because in DC analysis we consider the capacitor is open circuit. Kalau open circuit dia kira tak ada, and the voltage source ni kira ground. Okay, tak ada, so kira this one akan pergi ke ground jugalah. Okay, in DC analysis. Kalau in AC analysis, there are the conditions for the capacitor. If AC analysis, the capacitor will short. Okay, kalau the capacitor will short, dia consider base connect to the ground. Okay, base connect to the ground, so base, this one is for common base. Okay, for the common collector, this one consider as voltage source, kita consider as connect to the ground, ataupun dia consider tak ada value, so jadi ground for DC analysis. Okay, that is why yang ni, this one yang connect to the ground. Okay, sebab this one akan open kat sini, so open kat sini. For common emitter, yang ini yang akan connect to ground, base, collector. Okay, and all these three connections depends on the applications lah. Sama macam ni tadi, the purpose. Okay, antara these three, yang paling selalu apply is this one. Okay, you guys akan tak adalah sentiasa, yang normally akan ditanya is this one lah. Okay, common emitter. Okay, this one is for common base configurations. Kalau for common base, the base is connect to the ground. Yang ni, base yang akan pergi ke ground. So we have the current IE goes in, IC comes out, IB comes out juga. For PNP, kalau for NPN pun sama, dia akan flow by, please observe this one. Okay, this one here, what is the difference is on the polarity of the voltage source. Nampak tak beza dia? Okay, because for this one kita nak current flow naik, yang ini kita nak dia flow by this way. Okay, for PNP. This one for NPN dia nak kena masuk. Okay, yang ini from here. Okay. So this is actually in the circuit, nanti kita akan pakai this symbol. Tak perlu lukis guna yang ni pun. Guna lukis yang bawah ni. Okay, meaning that you need to know each of the terminal dia. C, B and E. Position dia. Okay. The base is common to both input and output. Explanations for common base. Base is common, maksudnya base yang dekat tengah tu connect to the ground. The base is usually at ground potential equals to 0. Current directions we refer to conventional hole flow rather than the electron flow. Meaning that depends on the polarity of the electric field yang kita apply lah. Okay. But then the concept is still carry the same. IE equals to IC plus IB. Okay, this is for operating region. Ataupun this one, you guys dah biasa tengok pun in chapter 2, the IV characteristic kan. Tapi ini lagi detail sebab kita ada value for each of the terminal dia. Kalau sebelum ni in chapter 2 dia cuma I dengan V. Now we have the IC and VCB. Okay, VCB position dia adalah okay, dekat sini. Plus, minus, plus, minus. So ini adalah VEB. This is VCB. Because in between C and B. Okay, VEB is equals to VBE. Dia terbalik daripada VBE lah. Equals to 0.7. Katakanlah VBE is 0.7, VEB minus 0.7 all the time. Okay, dia kena terbalik sebab dia, kalau biasa kita base dekat atas, emitter dekat bawah. So that is for for VBE. Okay, base dekat atas. Kalau yang biasa macam ni, base, emitter. So this one VBE. Yang ni emitter dekat atas, base dekat bawah, so dia terbalik VEB. It's like kita measure dekat same node tapi kita terbalikkan position dia. Tu yang dapat value yang sama, but then it has minus 0.7 volt. Get it? Faham tak yang ni? Same value tapi kita measure dekat point yang sama, cuma kita terbalikkan position dia. Satu atas, satu bawah. Okay, sebab tu kita dapat polarity yang terbalik for the VBE. Okay. Right, this is the operating region. IV characteristic. This is for IC versus VCB. VCB dekat sini tadi. In between emitter to base. Okay. Okay, this is the output collector characteristic for common base, and we consider for this one we consider IB is equals to 0 because kenapa? Kat sini kan dia pergi ke ground kan? This one connect to ground, so IB is equals to 0 sebab dia pergi ke ground. We assume IB is equals to 0. That is why yang ini dia terus tulis IC approximate to IE. Okay. Operating range of this is the active region for operating range. Remember for the transistor normally kita apply dalam switching ataupun dalam amplifier. Okay. So this is for saturation region ataupun ini adalah on. Okay, this is for cut off is off. Okay, for cut off, what is position for cut off? IC equals to, ada value tak? Kalau cut off region yang bawah ni, there is no value of current kan? Sebab tu off, open circuit. in open circuit kita ada voltage tapi kita tak ada current. Okay, that is why this one is for open circuit. Okay, for switching dia off. Okay, for this one dia on. We have the IC, we don't have, it is short circuit. Okay, VCE is equals to 0 for this one lah, saturation region ni, yang ni. Okay, and this is the operating region. Yang lain ni semua dia operating region. Okay, for active operating, this one dah tulis dah, operating range of the amplifier. Okay. Kat sini value of the IC, but then here dia tulis value of the IE at the respective line lah. Kalau IE dia 5, so this is point untuk IC, point untuk the VCE dia. Okay, so ni bila kita depends on the operations lah. Bila kita contohnya kita inject on the value of IE berapa-berapa, so dia akan effect on the IC and goes with the VCB. Okay. IC is an output voltage IC to an output voltage VCB for various level of input current. IE is input. Kalau tengok balik dekat sini, input dia is the IE. Kat sinilah yang kita akan connect with the V in. Okay. Ni, this one. Ni V in. So this is input, this is output. So input is connect with the emitter. Sebab tu emitter akan jadi the input. Same goes for here. This one depends on the input, berapa yang kita inject. Okay. Alright. So from the curve indicate that the first approximation relationship between IE and SE in the active region is, we have this one because IB is approximate to 0. Sebab base is goes to ground. VB is equals to 0. Tetapi we have this VBE value ataupun VEB equals to minus 0.7. This one will not be given for this value VBE. You need to know. Okay, dia tak bagi tahu dah ada value. Alright. So this one we want to relate with the alpha and beta. Alpha is the relates of DC current IC and IE. Alpha DC, kenapa dia ada DC? Sebab this one is enduring DC analysis. Okay. For AC mode in AC analysis, we have alpha AC. This is the changes in the IC and IE. Perbezaan dia. This is straightway on the value itself. Okay. Okay, by default, the value for alpha is approximate to 1. That is why we have the IC alpha IE plus ICBO, the majority carrier. Okay. Alright, so this is contoh calculations to measure on the IE, IC and voltage at V out. This one is, katakanlah ini adalah V out, ini adalah V in. Okay, the given V in. Okay, why for this calculation dia tak suruh cari IB? Kenapa? Equals to 0. This one kan ground, or this ground. Okay. Alright, so IE is equals to I in. Why dia tulis macam tu? IE equals to I in. Because ini kan input kan, this is input, so this is equals to I input equals to IE, sama lah. Okay, so we have the This one dia bagi R in. Contohnya kalau kat sini lah the resistor R in tu. Okay. So V in over R in. V in the value dia 200 over the value of the resistor. Terdapat this is for IE. Okay. And then since we have the IE equals to IB plus IC, but then because of IB is equals to 0, this one, so IE is approximate to IC. Sebab this one tak ada current, so current datang sini dia terus keluar. Okay, actually IL is equals to IC, kan? And then equals to I because there is no current dekat base, ataupun equals to IE, the same value. This one lah, sama tak? Okay, so now we want to get the value of VL. Macam mana? Kita dah ada the current, macam mana nak dapat value of VL? Darab je lah kan? So VL is consider VL is equals to V out sebab dekat output. Okay, so dapatlah 50. Input kita berapa? Output kita berapa? So AV is equals to, AV tu apa? Voltage gain. So it is the ratio from output to the input. Okay, so dah dapat value tadi over the input. This is the voltage gain of this circuit. For this output ni maybe kita letaklah, okay, 100 kita tak guna. So for this maybe for this R out ni, the connections kat tengah ni ke? Okay, so this is 250. Remember for the gain, is there any unit for the gain? Voltage gain or current gain? Ada unit tak? Yes, because this one kan voltage over voltage, dia ratio, so dia tak ada unit. Okay. Okay, second one we go for common emitter. Okay, common emitter dia macam ni. We have this emitter connect to ground. Okay. Alright, so IB masuk, IE goes in, we have the IE. In between here we have VCE. Here is VBE. Here is VCB. VCB. Okay. And this is collector characteristic, IV characteristic for common emitter. IC and IE. Okay, this is summer saturation region, this is cut off region. As you compare this one dengan yang tadi, this one is dia nak naik tu lambat, lepas tu dia maintain je. But then for this one, dia nak naik tu very fast, kan? Yang ini, especially untuk dekat voltage, dekat value I yang makin besar ni. So fast switching for this collector, common emitter, common emitter configuration. Okay, sebab tu this one it has high voltage gain and high current gain. Okay, this is by ideal the current. And then this is the actual current, tetapi we just ignore on this one. Okay, and ditulis kat sini IB is equals to 0 microampere in cut off dekat bawah ni. Okay, in off region. But there is some minority carrier current called ICEQ, ataupun this one is consider as the leakage current. Tapi this one is a very small value, so we consider as 0. Dia macam ada tapi kita tak kira in calculation. Okay. Alright, so now kita nak pergi to beta value. Beta and alpha is the ratio ataupun amplification factor of a transistor. Okay. And this one, yang ni is dalam AC equivalent circuit. Nanti kita akan jumpa for the HFE. Okay. In DC, beta sama juga dengan IC equals to beta IB. This one you kena hafal. IC equals to beta IB. Okay. For this one, kata kalau kita dah ada IB, dah dapat the value of IB, then kita boleh dapatkan the value of IC from the beta value given. Okay. So this one, yang kotak merah ni, you need to memorize this one. Will not be given dekat dalam soalan. Okay. Beta value akan diberi. Beta value will be given. Alright. So this is to get on the beta value. We just keep this one kot. I think tak perlu. Oh, okay. It just nak tunjuk from the IV curve ni, kita can get on the beta value because beta is equals to, this is IC over IB. Okay. Sebenarnya dia datang daripada from the 2 point 3.2 dengan 2.2 minus over 30 micro over 20 micro. So boleh dapat the value of the beta. Biasanya kita akan guna one value sahaja for the beta. It will be given only one value. So you just use value yang diberi dekat dalam the circuit tu lah. Okay. Next one, kita nak pergi to common collector. Okay. For common collector, dia akan terbalik from the common emitter. Collector is at the bottom, yang tepi. Okay, yang tepi pula, yang bawah. Okay, so collector will connect to the ground. So we have the IE goes in, IB akan keluar. Okay, yang penting is on the polarity lah, dia punya ni. For NPN, IC masuk because that one the sintesa akan keluar for the NPN. Okay, so dia akan keluar. Both is goes in, IE akan masuk. Okay, this one beza dia dekat sini, nampak tak? Yang ini dia akan flow by this way. This one dia akan flow by this one. Sebab tu dia dapat current masuk dekat IC tu. Okay. Terpaksa je jawab. Nampak dah mengantuk sangat dah madam. Bila nak habis ni? Laju je Izri mengangguk ya. Okay. Please ya, kalau rasa terlalu teori, balik please tengok semula. Because this concept penting untuk kita, you kena faham. Because nanti bila kita nak buat DC analysis, DC analysis apa benda lah pula madam ni. Okay. Kira dia punya, dia ada dua part. DC analysis yang kita nak measure on the current and voltage. Kenapa kita nak measure that one? Because kita nak dapat dia punya voltage gain. So kita kena kira lah current dengan voltage dia. Okay. And for the AC analysis, kita nak tukar the circuit from the, bukan yang ni, from this circuit. Contohnya mana tadi circuit? From this circuit, kita nak convert into AC equivalent circuit for small signal AC analysis. Okay, kita untuk AC analysis kita tak guna this circuit, kita tukar into circuit yang lain. This symbol kita tukar into simbol yang lain. Okay, itu lagi kompleks sikit. Sebab tu saya cakap for chapter 3, saya tak estimate boleh habis dalam 2 weeks. Maybe 3 minggu. Okay, kita cubalah. Okay, so this one is for common collector. Okay, we will just go laju sikit yang ni. For common collector dia sama je, but then you need to understand on the current flow lah. Okay, this is same goes for the common collector. Dia ada apa? Ada voltage ke ada current gain? Ada apa tadi? Common collector ada current gain. Okay, so dia akan cepat dekat saturation region. This one bukan common collector. Okay, common collector dia akan cepat dekat saturation region sebab dia ada current gain. Okay, so from all these three graph, yang paling cepat switching is the common emitter. Okay, dia cepat naik. Contoh macam ni lah, lagi tinggi dia current, lagi cepat dia naik. Okay. Alright, so this is the power dissipations. Dekat dalam all of the terminal, dia ada power yang akan dissipate. So this one is respect to the voltage yang kita measure. So this one for common base, kita ambil VCB. Okay. For common emitter, kita ambil VCE. For common collector, kita ambil VCE. Why for this common collector, kita ambil IE? Okay, because all the IC common kan? So kita tak nak ambil on the common one. Okay, kita ambil on the common emitter. IE. Okay. This is the explanations on the power dissipation for common emitter, common collector and common base. Dah ramai yang mengantuk, I will just skip this one. Please go through and baca balik. Okay, this is data sheet for the transistor. Transistor ni je sebenarnya. Kalau you guys biasa tengok yang warna hitam, ada 3 pin. Okay, and then dia ada satu side melengkung, one side for surface flat. So yang flat tu adalah dia punya depan. Okay, and important for this transistor, bila kita nak connect dekat dalam the circuit, yang penting to determine each of the kaki. Kalau tersalah kaki dia, you akan salah connection. Sebab kaki dia satu-satu akan ada dia punya value base, collector and emitter kan. Okay, so yang penting untuk tahu dia punya terminal dia lah. Okay, this is the spec. Oh, dah habis lah rupanya. Tak ada. Sem lepas saya dah prepare siap-siap. Untuk semester ni nantilah kita buat for the learning. Okay, ada soalan tak? Basically this is all the theories yang related lah. For chapter 2 3B, kita akan masuk on the calculations of the DC. And calculations dia, please, kalau siapa yang belum betul-betul faham on the KVL, balik do some tutorial on the KVL, because dia akan carry the knowledge to do the KVL. Okay, buat KVL dekat dalam the circuit. Contohnya kalau di circuit mana tadi? Okay, okay, di circuit kita akan do the KVL, nak cari IB, nak cari IC, nak cari IE. Same goes with the voltage for each of the terminal. Itu yang kita akan kira. Okay, and this one, kalau you tak berapa faham tu on the KVL, dia agak struggle sikit lah. So balik please do some tutorial on chapter 1. Okay, ada soalan tak? Kalau tanya saya, antara chapter 1 to 3, chapter 3 yang paling agak mencabar for mechanical student. Tapi once you faham the concept, insyaAllah boleh je buat. Janganlah takut pula. Okay, where is the attendance? Any question? Zarif, ada soalan? Please ya, kalau tak faham tolong tanya. Sebab this chapter 3 will carry 20 marks tau. 20 marks dalam test.